Hello and welcome back for another action-packed VMK in the game development series. In this VMK, we're going to implement the monospaced fonts inside our game engine so that we can print items onto the screen. This is pretty cool because finally we get text on the screen. It can be static as well as it can be dynamic. So while your program is running, if it's calculating certain numbers or certain things, you can now display these items onto the screen. This will also allow you to get rid of the frames per second counter in the title bar and actually put it inside the window itself. And you'll notice that by changing this, there's going to be a huge performance increase because we're no longer going to be creating and destroying memory every time in our frame. And I'll talk about this in a minute once we go through the code and start making manipulations to it. So let's get started. We left off last time with implementing the font.cpp and font.h class files. So now what we need to do is change the scene class so that we can use the font engine stuff within it. These changes are going to look very similar to what we did here with the lights as well as what we did with the textures. Again, we need to store our items inside of a vector just like we did here, but this time we're going to be storing our fonts. And then we need to add extra functions up here to access our fonts, to delete them, and things like that. So let's start off with the functions. There are three new functions we need to write to access the fonts. We need to write an add font function, a delete all fonts, and a print text. The add font function will allow us to add a new font into our list, into our vector. Delete all fonts is going to be called inside the destructor, so it's going to remove all the items that we've previously stored using add font. And lastly, we have print text. This is the function we use to print stuff to the screen. Down here, under all textures, we're going to add, we have a std vector which contains font pointers, and I'm going to call this m_vp fonts. So this is going to be the container that holds all of our fonts. Underneath that, I have a member variable here called sz_text_output, and it has enough space to hold 128 characters. So in other words, when you're using the print text function up here, you'll be able to specify a parameter. The very last parameter here tells you what you want to print to the screen. Well, all that text will be stored in this member variable, and you can only store up to 128 characters. If you find that this is too limiting for your specific game, you can go and up this number to whatever you want. I just chose 128 off the top of my head. It seemed to work for me. Okay, let's go into our scene.cpp file now, and underneath the initialize here, at the very bottom, after we handle all the textures that we've loaded, let's go in and add a load font. This is how it's going to work. We're going to create a node texture because all of our fonts are stored inside of a texture. So we need to use a node texture, and we're going to call load texture same as we did before. But this time we're passing in the file name to our font here. This is going to return to us a texture ID number, which we pass into add font, which is this new function which we're just going to be writing. The other parameter we need to pass into add font is the size of our font that we're loading. There's no way for us to predict the size of each character inside our texture, so we need to specify a parameter here. As I was saying in my previous VMK, the current textures we're using are going to be 50 by 50 pixels in size. So this is where I specify the 50 parameter. Something else you'll notice is that under resources now, I've created a folder called fonts. And under there, this is where I'm going to be placing all the textures that are associated with fonts. I could have put them under textures, but I felt I wanted to separate these two items because fonts are really text-based items, whereas textures could be anything, could be graphics, things like that. Let's take a quick peek here at this large impact underscore mono1.tga file, just so that you see what it is that I'm going to be loading. Here it is here. It's exactly the same font that I was showing you in the previous VMK. It's all spaced out so that there's 10 characters per row and there's 10 rows of text. These last 5 parameters here are blank, so there isn't any characters in here. You can go in and add other characters here, but to print them is going to be very difficult because you don't have a mechanism to do that. The font itself is printed in white, and the background is black, but the black background will not show up because I have a mask in this texture. If I go under Layers, Load Mask from Alpha Channel, you'll notice here's the mask. The mask covers up all the black stuff, and it's going to leave all the white stuff visible, which means all the text here will be visible, all the black stuff will disappear when we render it in our game engine. Okay, back in Visual Studio, let's go and write this add font function now. I'm going to place this function right underneath delete all textures. So I'm going to select delete all textures and just place it right here. Okay, add font. We pass into it a texture ID and the font size. If the texture ID is less than or equal to 0, then that means that our load texture function call failed and we can't do anything with the font, so we just immediately return 0. Then what we do is create a pointer to our font, and we call the new operator on the font constructor. We pass to it the air handler, the renderer, the texture ID, which is passed in here, and using the vector that contains all of our textures, we go and extract the size of the texture. We pass that parameter in as well, and then we have our font size, which is the 50 that gets passed in, and null. Null here is being set up for the last parameter, which, if you remember from the previous VMK, was a pointer to the spacing. This won't come into effect until we write the next VMK, where we're going to be working with proportional fonts. Right now we're only working with monospace fonts, so there are no spacing, so we're just leaving this blank here, null. If pfont returns true, we can add this into our vector here. Then what we do is we take the size of the vector and we return that out for this function here. So in other words, this function add font is going to return to us the ID number of the specific font. We can then use this ID number to select which font we want to use whenever we're rendering text on the screen. So we'll know that the first one that we load is going to be font ID 1. So if we want to print text using the first font, we'll specify we'll print text with ID 1. Same as we did with the textures and the lighting as well. We return 0 here if this new operator fails. Now, you may remember that our node textures here didn't have a function called getSize. So we need to go and write that function. It's just going to be a very simple function because it just needs to return the size of the texture. So let's go inside node texture here and add this new function. Inside the class, I'm going to make a function, just call it getSize, and it's going to return an unsigned integer. And then inside node texture.cpp, right at the very bottom, I'm going to add that function. So we don't get any parameters passed into getSize, so what we do is we just return the width of the texture that we loaded up above. The width is equal to the height, so in other words, it doesn't matter what we return. We could return the height, but they're both equal. I just chose to return the width. Let's just compile that to make sure that's okay. Okay, and then let's go back into our scene. Okay, so we finished writing the add font function. Now let's go write the delete all fonts function. So going back into scene.cpp, right underneath add fonts, I'm going to add the delete all fonts. What we do is we go inside our list that contains all of our fonts. So we start from 0 and we go to the full size. And for each one, we go and call the delete operation. So this will go and call the destructor of every single font class that we've saved. Lastly, we go call clear on the vector here to make sure that we remove all the items that were stored inside the vector. Now, we need to call this function whenever our destructor gets called from our scene, which means we need to add it here into the clear all function. Just like that. So that takes care of loading the fonts and clearing the fonts once we're closing the game. The last thing we need to do is write the print text function. This function will allow us to print the text to the screen. So going back into the scene.cpp file, right underneath delete all fonts, I'm going to write the function for print text. So with print text, we first check to see if the font ID number is valid. So if it's not valid, meaning it's equal to 0 or it's greater than the size of the vector containing all the fonts, then we generate an error message here. If everything is okay, we'll go down here to this next section. Now this next section works exactly the same way that our set error function for the error handler works. We pass in some string text here to the very end. So what we do is we take that string text and we parse it using va_list, va start, vs printf, and va_end. And during this parsing, what happens is all the text that gets passed into us gets saved in that member variable here. And again, this one here will only store 128 characters. So make sure that you don't call this function with more than 128 characters being passed in. Then what we do is we choose which renderer we're using. We're going to be using OpenGL. And by selecting the font ID number, -1, because again, the vector here stores everything starting with 0, whereas we're going to be returning ID numbers starting with 1. So we need to offset our number here by -1. And then we call the print text OpenGL function. This is what we wrote in our last VMK. We pass to it the x and the y coordinates, which were x and y passed into this function. We pass in the scaling factor, which also was passed in here. And then we pass in the text that we want to display. And this text happened to be calculated for us here inside the print text function. And that's all we have to do. Now, the big question remains, where do we call print text? Well, if you think about it, inside our render function would make most sense, right in here. However, let's take a look to see what happens if we do this. So what I've done here is I call print text. I'm going to use the font ID number 1, which means the very first font that we're loading. I'm going to position the text at 0, 0, so it should be in the center of the screen. And then we have our color that we want to use. I'm choosing to use black. The size of the font is going to be the original size inside the texture, so I'm using 1 here. And the text that I want to display is font testing. Let's build this and take a look at what happens. Oh, we got a couple errors here. All right, here we're using font. Here we're referring to the font class. However, at the top we never included font.h. Okay, let's try building that again. We still have some error messages. Oh, we're missing a slash here. Okay, that looks okay. Let's go run it. Notice that we don't see any font on the screen. Well, the reason for this is because inside this update, we're rendering objects in 3D space. But with the font, we want to display the font in a 2D plane right in front of the 3D world. So it needs to be projected into a different coordinate space altogether. Doing this forces the text to be rendered at 0, 0 with a scaling factor of 1, but this scaling factor is actually huge. Remember, our text was 50 pixels wide. Well, when we're rendering here, it's actually 50 units wide, which means the size of the text is humongous and it doesn't display on the screen. What we need to do is delete this from here and incorporate a new mechanism to render the font on the screen. To do this, we're going to split up our rendering calls. One, we're going to render things in 3D, and then after we're done rendering all that, we're going to go and render things in 2D right in front of the screen, laid over top of everything. This will allow us to display the text properly in the screen. Okay, so we need to go back into our game engine and inside game OpenGL. Looking back inside the initialize, we'll see that we do a bunch of initializations and then we set up this projection matrix here. Well, we're going to delete this from here. We're no longer going to need it, and instead we're going to move it to a different location. The projection matrix will now be handled inside render pre. Actually, before I talk about that, let's go take a bigger look at the frame here. Every time through our program, we're going to be calling frame. And inside frame, we call update game, which is down here. And inside update game, we handle the keyboard, handle the mouse, update the player, and then we have render pre. After we're calling render pre, we go and call update for the scene, and then we have render post. Well, the projection matrix now is going to be updated in render pre because here we're going to select to render things in 3D. We'll go and render things in 3D, and then after that, we're going to change to render things in 2D down here, and then render things in 2D. And after that, we're then going to go call render post. So let's go into render pre. And right at the top here, we're going to include that projection matrix stuff. To clean up the code ever so slightly, I'm going to create a separate function called setProjectionMatrix. And this is going to have the code that we just deleted from the initialize. So I'll put this function underneath start message loop. Just scroll down here, and I'll put it right above the initialize. Oh. Okay, so with the projection matrix, we're setting up the viewport, setting up the projection matrix to have 45 field of view, set up the aspect ratio, and the min and the max planes that we're allowed to render inside. The other thing we need to do is add this guy to our game OpenGL.h file. And I'll put it right here underneath message handler, right above initialize. Let's go and compile this, make sure that's all okay. Okay, and now that we've set that up, we can go in and add an extra function call to change from 3D view to 2D view. So going back into the update game, after we render everything in 3D, down here we're going to change the projection matrix to be orthogonal, which means two-dimensional, and then after that we're going to down here call a function to render the text onto the screen. Let's define this set orthogonal matrix inside the .h file. And we need to create this function as well. So I'll put it right below set projection matrix. Okay, and with set orthogonal matrix, we again need to set the viewport, and then we set the projection matrix, this time using GLU ortho 2D. And then we specify 0, the width, 0, and the height. Doing this will give us the coordinate system so that 0, 0 is located in the bottom left-hand corner of the screen. And the top right-hand corner of the screen will be equal to the width, comma, the height. So that's the new projection matrix that we're going to be using when rendering text to the screen. Going back inside update game, we can now say down here, we want to create a function that allows us to render things to the screen once we've changed this projection matrix. So we're going to put this function inside the scene class. So I'm just going to actually, let's add it to the scene class first, and then we'll call it here. So inside scene.h, scrolling down here underneath update, I'm going to add a function called HUD. HUD is an acronym for heads-up display, and that's basically what we're creating here. No matter which way we're going to be pointing in the screen, this text will always be shown up right in front of our faces. So in other words, it's going to act as a HUD does in any other computer game. Now let's go into scene.cpp, and I'll put the HUD function right at the very bottom here. So what this is going to do is update the HUD display, and every time through here we're going to just print the text to the screen. And again, 00 is going to be located at the bottom left hand corner. So we specify we're going to use font number 1, location 00, the color remains black, scaling is 1, and the text we're going to try to display is font testing. So let's save that, and then now we can go back into the game OpenGL.cpp file and use that HUD function here. Okay, I think that should be it, and we should now be able to see text on the screen. And we do. Look at that. So notice that no matter which way I'm facing, the font is always being displayed on the bottom of the screen. That's because this orthogonal projection matrix is done after we do all the 3D stuff. So the way it's set up is imagine having like a screen right in front of the 3D world, and we're just printing things onto that two-dimensional screen. Now let's play a little bit more with the font on the screen. Let's move it up a little bit. So let's go to 10, for instance. And you'll notice now it should be a little bit higher on the screen. And it is, ever so slightly. So it's not right at the very bottom anymore. If I wanted to change the color, we can go in here and change these parameters to whatever we like. So I can give it a more red color. We'll just change the first parameter to 0.8. Got to compile it again and run it. Now the text didn't turn red. Why is that? Yes, I remember now. There's one other thing we need to change to make sure that the text is rendered properly on the screen. Going back into our nodeLight class, let's take a look at the constructor here. Anytime we create a new light source in our scene, we'll go down here and we'll enable lighting, we'll enable color material, and then we set the maximum number of lights. Well, for our text to work, we need to make sure we disable the lights. And inside of our scene class, we have a function called lights disabled. However, you'll notice that nowhere in here do we ever go and disable the lights. We turn them off, but we don't disable them. This function here, which is supposed to disable the lights, actually goes in and disables a specific light, which means turns off a specific light, but doesn't mean that OpenGL turns off all lighting calculations. So what we need to do is modify our nodeLight class slightly to take this into consideration. Going back into the constructor, where was it? nodeLight constructor, right here. We can go and remove these two items, and we're going to place them in a different location. The first enable, which was the GL color material, we'll go and we'll locate that inside the game engine. Inside initialize, if we scroll down here, we can put it anywhere, so I'll just place it right after the GL blend function. So that's going to turn on the color material. Now we also need to call GL enable for the lighting. And this function will go into our scene under lights enabled. I'll put it right underneath this counter. So anytime we want to go and enable the lights, we make sure we turn OpenGL's lighting engine on, and then when we go and disable it, we can then go and call the disable as well, which I'll put right here. Okay, so now whenever we enable lights and disable the lights, OpenGL will turn on and off the lighting engine appropriately. Now let's go take a look to see whether our text is red. Oh, and it is now. So before, it was still black because the lighting engine was turned on. It never got turned off. And because we don't have normals defined for our text, everything was just rendering to be black. And it just so happened that I didn't notice it the first time around because I also selected to have the text be black. So again, if I go and change this to red, green, blue, so this text now should be green. If I go and build this and run it, we should see that our text indeed looks green. That should get you up and running with the font engine using monospacing fonts. Now in the next VMK, we're going to go and modify our existing code for proportional space fonts, and then I'll also talk about how to display special characters on the screen, because there are a few characters that if you want to place inside here, they won't display properly, so I'll talk about that. And I'll also show you the differences between font sizes. So we'll play around with this parameter here, and I'll describe to you what it means to have large font as opposed to small font and so on. So hope you come back for the next VMK. Have fun playing around with the text.